And we are live. So hello everybody, this is Go Miami. I'm Bill Kennedy, and tonight we have a really special guest with us, Matt Sherman from Stack Overflow. He's going to show us some very cool things around type-driven code generation in Go. So Matt, I'm going to take it over to you now.
All right, great. I'll show you my beautiful face here for just a second. Hello, my name is Matt Sherman. I'm talking to you from New York City at the Stack Overflow office. That's my day job, and people tend to be here late. It's late here. That's New York City behind me out those windows. You probably can't tell. So we'll go ahead and jump in and talk a little bit about type-driven code generation and a product called Gen. We'll do our best to take questions just because of the format here on YouTube. It's not exactly real time, but we'll do our best. You can tweet me at Clipperhouse if you want. You can talk in the room there. Bill, is there any other way to get in touch with us? We have a chat room for Go Miami. Is that right?
Yeah. So on the Slack group, there's a Go Miami channel. If you go there, there's a couple people there now, and I'm there, and Ed Gonzalez is there as well.
Okay, so that's gophers.slack.com. Is that right?
Yep.
Okay, great. So yes, feel free to try to interrupt. We'll do our best to keep up with questions if they come up. So I'm going to go ahead and share my screen here. We're going to have an inception moment for just a second. And we will jump in. I'll have a relatively small number of slides here. So Gen. Gen is a tool I've been working on for about a year. It's in Go. And what it does is type-driven code generation. So are you still seeing me, or are you seeing a screen share? Looks like you're seeing me. Oh, no, that's okay. Never mind. So what does this mean? Why were we motivated to do something like this? Well, code generation makes some things convenient. One reason we do it, so there's a lot of tools out there that take interfaces as types. But what if you're used to sort of generic programming in other languages? You're used to things being generic but also strongly typed at the same time. That's what I was trying to address with this. I come from a C# background, so I'm a bit spoiled as far as generics go. That's a very important part of the language. So I wanted to see if I could find a way to sort of get those benefits in Go. So among the things that it gets you is compile time safety. So if you're passing around the empty interface type, it works, it's fine, you do type assertions against it, but you get a little more type safety if you use real types, so you know you're not making a mistake. And by type safety, I mean compile time safety. It gives the compiler an opportunity to tell you what you're doing, right or wrong. And it's also possible, I wouldn't commit to saying this, but it's possible that you'll get better performance, but that really does vary. It's easy to assume that strongly typed systems are faster, but that's not always true. It's often true. It gives you a few more opportunities to sort of optimize performance. If you can avoid reflection at runtime, reflection can be relatively expensive as well. So why are we doing code generation? Well, I've been doing this for about a year, but it's become a bit validated lately, which I'm happy about. You may be familiar with the GoGenerate directive, the GoGenerate tool that came with Go 1.4. And the idea there was to basically make code generation a first-class citizen in the tool chain, basically, and to be able to mark up your code base with code generation. So, and I've talked to Rob Pike about this a little bit, and code generation actually is becoming sort of a validated way of going about things. So, generics. That's what drove me to this. It turns out, so I started looking into generics implementations a little bit. Turns out they are a lot like code generation. It seems mystical, magical that you can pass in a type as a parameter and it does the right thing. Turns out, a lot of the time, it's literally just sort of a code generation replacement that happens at runtime, which is done either by a JIT or by the compiler, depending on the situation. So essentially, you have code that has type-shaped holes in it, and you swap out a type. So that's where I came to with Gen. So let's treat generics as a text problem. It's actually not that crazy. We generate code at dev time locally, so Gen is a tool that assists you while you're developing. It's not something that runs in your code. You don't put it on the server. You generate code at dev time locally while you're using it. You commit your code. It's your code just like anything else. So Gen is a tool that helps the developer. It does Codegen to the extent that something like an IDE would do Codegen. It spits out a bunch of code for you, but it's not special. It's your code. It's just a tool to sort of help you out. And the way we go about this, so the idea is that it's very type-driven. So the way we go about this are what are called type annotations. And you'll see an example at the bottom of the screen there. And I'll go ahead and illustrate what this means in just a moment for you. But the basic idea is you mark up your types with the sort of code generation you want. So bear with me for one sec here. So now I'm going to flip over to do some code, and this is where we sort of pray to the demo gods. This will be fun. Okay, so we've got a type here. So I've got a little bit of boilerplate code going here. A person struct, a couple of types to go with it. We don't need that type anymore. So it's all pretty straightforward here. Let's go ahead and do this just to demonstrate what I'm talking about. So I'm going to mark up this type. I'm going to say gen, so that's our directive. And in this case, the kind of code that we're going to generate is a slice. You can generate any sort of code with gen, but it's got a few things that are built in that sort of make it easier. So here I happen to know some of the methods that are available. You'll recognize these things as struct tags. So I'm going to do a couple of things here. I'm going to say these are the things I want to generate, okay? So I'm going to save my code. I'm going to come over to the command line here. I'll actually go get it just for the purposes of demonstrating this. Go get github.com/clipperhouse/gen. Good. And now I'm going to, bear with me here, source, GitHub, Clipperhouse, Miami. Now I'm just going to type gen on that file. So we're in this directory here, okay? And we're going to type gen on that file. Goes and does its thing. Doesn't give much feedback. It's a quiet tool for the most part. Come back here. This is Sublime Text. We've got this new generated code right here. And it gives us this new type called a person slice. Why do we do that? Well, it gives us a bunch of nice functional methods here. So in the case of what we did here with this slice, I come from a background where we have something called link, which is a very nice sort of functional system for doing filters on collections, that sort of thing. So what we'll see now is if we come back here, I'm going to go ahead and uncomment this right here. So I've got this sort of queued up, ready to go. I'm going to create a new person slice with a bunch of data in it. Okay. Come back to our main here. I'm going to say funct print line persons. There it is. Save it up. And now we're going to go ahead and run that. So I'm going to say go run. So go. And we just see the things that come out. Straightforward enough. So we just got a bit of data in there. Okay. Again, just to review the data that's here, looks something like that. So we have a name, we have an office, and we have a sales number for each of these people. Now let's take advantage of some of those new things that we generated. So let's say I want to filter. Let's see, who do we got in here? Let's take a look at just the New York people. So we'll say where. We have to pass in a function. I'm going to do this function as a local variable just for clarity. So I'm going to say the New York filter is a func that takes in, it's an anonymous func, that takes in a person and returns a bool. You'll be familiar with this pattern. You may have used it in underscore as a filter, something like that. So I'm going to say return p.office equals, let's say, New York. I'm a little biased. And then I'm going to pass in my function here, save it up, and we're going to go back to the command line. So just to review, we've defined a function here. We pass in the function to do this particular filter. And so we're going to go ahead and run it again here. And you'll see that we filtered for New York. Now, of course, we could do this with a loop, but what I'm really going for here is the ability to give us sort of a more functional paradigm here, where we pass around functions as a matter of course. I'm going to go ahead and let's see. I'm going to go ahead and add another thing here. Select. Yeah, let's say we'll select out dollars. Okay, I'm going to come back here. I'm going to gen one more time. Okay, looks good. And what has happened now is we've actually generated some more stuff here. We've got a select here. Okay, so I'm going to select. Now, select is what you would call a map in other languages. So, so in this case, I want to pull out the dollars. So I'll say sales equals a func that takes a person and returns, what did I say, dollars? Okay. And coming down here, so I'll say return p dot sales. Okay, so I'm going to change something right on here. I'm going to say select dollars sales. Okay. So we're sort of building up a set of functions that I can pass through here. So again, select comes from sort of a link syntax. It is like a map, basically. It is a projection in other terminology. So I'm going to go ahead and run that one more time here. And you'll see what we've done now is we've selected out the sales numbers for people in New York. Okay? So again, if you're used to something like underscore or something like link or other sort of functional paradigms, you're pretty accustomed to this sort of thing. So it's nice to have that sort of pattern in Go. I find it sort of very readable. Okay? So this is just sort of an example of where we can start. Now, I've said, we're talking about underscore here, we're talking about link here. Gen is not really strictly about that. It's about the ability to generate things. And in this case, this is just an example I've used, is slice. But anything that's driven by a type, anything where you would say of t, could work in Gen. So another thing I adapted recently is Rob Pike's stringer. Okay, actually, I'm not even going to put it here. I'm going to go off script a little bit and show you how we can adapt other code gen. So you may have heard of Stringer. It's Rob Pike's tool. You can go ahead and Google Golang Stringer if you're curious about it. It's kind of a nice thing. It gives you nice readable constants. So I'm going to say Rob used something called pill here, int, and then, nope, don't want that. I'm going off script here, so bear with me. Const equals. Oh, I'm sorry, I'm getting off track here. I'm going to skip that for now. But basically, trust me when I say you can use other things to plug them in here. All right. So coming back to our presentation here. So the idea, the reason that this plays well with GoGenerate is that GoGenerate, as a little background, GoGenerate allows you to put in any sort of command line into your code. It's an annotation of its own that basically says when you run GoGenerate, run this command line. Well, if something is type-driven, I like the idea of having slightly better markup for this. So this markup I'm showing you here is entirely correct, and it works, and it's great. But wouldn't it be nicer if you could do something like this? So the idea here is that Gen associates your types with the thing you're generating. I call it a bit more semantic. So in this case, it looks like a command line call, and you have to send in a type parameter. But over here, you don't even have to send in a type parameter because we're marking up a type. And so you can imagine if you're doing a lot of type-driven code development, you could go about it that way. And then use GoGenerate as you like to, and just call Gen as a part of that as well. So again, it's sort of semantic and self-documenting. If you're going to do code gen, and that code gen is going to be about types, Gen might be a nice way to do it. So let's go underneath the covers a little bit here. So how does Gen work? So Gen is pluggable. I showed you something that happens to work with slice. I started showing you Stringer, but that would have required too much typing, so I didn't go much further with that. But the basic idea is that Gen can run any sort of code generator. And these code generators are called Typewriters. Okay? And Gen loads them at runtime, as long as you satisfy an interface. So among the things you might consider doing here is maybe some sort of strongly typed JSON serialization or deserialization. Or maybe you've got containers like trees or queues or pools, and you want to do those in a strongly typed way. You would write typewriters for those things, and they are as they sound. They take a type and they write. The typewriter interface looks like this. It's pretty straightforward. So I have a typewriter called Slice Writer. I have a typewriter called Stringer Writer that satisfies these interfaces. In order for Gen to generate a file for you, we need to know the name of your typewriter. That's just a string. We need to know what imports you need to go with your file. And then we allow your typewriter to actually write into the file. And that's what this last method is here. So it's all really quite straightforward. So given a type, you can write arbitrarily into a file. And Gen will manage that whole life cycle for you. The basic architecture looks something like this, just to give you an idea of how Gen runs. When you type Gen at the command line, you fire it off. The individual typewriters register themselves. They can be any typewriter you want. They register themselves. If you've ever looked at the database driver code in Go or the image codec code in Go, it works the same sort of way. Codecs register themselves. Database drivers register themselves. Similarly, typewriters register themselves. So they make themselves known to Gen. They say, hey, I'm this thing called slice. I'm this thing called stringer. I can generate code for you. Then Gen moves on, continues on, parses your package. So when you call it, it looks in the current directory. It actually evaluates your code. So Gen is very respectful. It really is driven by your code being correct, basically. So it's not just simple, dumb sort of string concatenation. It's looking at your code. It's looking at your types and evaluating them. So it parses your package. Then it goes and tries to find those types that you've annotated, that you've marked up. And then we evaluate them. So we look for different attributes that types might have. Some types are numeric. Some types are comparable or can be ordered. These are things that we need to know in order to do the right thing. So for example, if you want to create a method called sum that can operate on a numeric slice, you can tell Gen in the typewriter, hey, only let this work for a numeric slice. If something's not numeric, send back an error message. So we really like the idea of correct types all the way through. And then essentially what happens after that is we take each typewriter and we take each type and we loop through all of them and say, hey, typewriter, here's a type. What would you like to write? We write that all into a buffer. We validate it syntactically. And then we send it out to a file. And that's everything you saw today so far. The typewriter package is actually where the guts of most of this are. You'll have to take a look at it to know a bit more about it. But the typewriter package, which underpins Gen, does all that tag parsing. So the tags you saw earlier where I said, slice colon equals or colon quote where and group by. It's got a fully featured parser in there. We do all the type checking, and we can enforce constraints on types. And then a bunch of things for template helpers. So most typewriters, they're not actually that complicated. It's just text templates using Go's built-in text templates, and you just substitute in values. So I know I'm glossing over it very quickly here, but template-generated code generation is actually pretty easy, pretty straightforward. And that's basically it. I hope you will check it out. The URL is here for the source. Also, if you go to that link, you'll see a whole bunch of documentation. Like I said, I went fast, so if you have any questions for me, let's go ahead and switch back to the Miami room there and let Bill moderate any questions you might have.
Hey, Matt, that was really amazing. I didn't realize how much work you had done already on this technology.
Well, thanks. Yeah, I've done quite a bit. I mean, it's sort of addictive, I started dabbling with it, and then I wanted to make it pluggable, and then I wanted to make it even more type safe if it could be. Yeah, so it's been a lot of fun. It's gone through about 4 revs now.
Do me a favor. Bring up your clipperhouse.github.io/gen because while you were talking, one of the things I wasn't sure of what was your code and what was actually coming from Go. So the only thing coming from Go is the call to GoGenerate, right? Everything else that you showed today is coming from your package here.
Yeah, that's right. Yeah, so well, say that question again. So what do you mean by that? Yeah, most of what you saw today, all the code that got generated is coming from my package, if that's what you mean.
Yeah, yeah.
And GoGenerate, it just plays well with GoGenerate. It doesn't require GoGenerate. I didn't actually use GoGenerate today, but it plays well with GoGenerate if you like that pattern of development.
Oh, so everything we saw today was your package. You're doing this generation of code. Correct. Wow. And yep. Ed and I come from a .NET background, so I immediately saw how it seemed to me that the comments that you were writing were very similar to like attributes on a type in .NET. I thought that was really clean. Yep. And then the way you're using functions is brilliant. And when I saw this page that I just asked you to bring up, maybe I'll bring it up too. It all kind of made a little more sense to me. Is that it right there? Yeah. So once I saw this, and I'm seeing the typewriters you talked about, but then here's all the operations that you could generate for a slice, right?
Yes, and slice is just one typewriter that I build in by default. So I can show you, actually, I'll show you something. I'll do a little more screen sharing here just to show you something kind of fun. Let's see here. I guess I'll do the entire screen, always a little risky. So I'll close this one up. And I'm going to go show you how to add a third-party typewriter. Let's see if this works. Again, praying to the demo god. So I'm going to say gen. So you want a third-party typewriter, one that doesn't come built in. It's just like an import. It happens to be under my namespace, but it doesn't have to be. So a common thing that people like to see in Go is a set, just sort of the common set metaphor. So I'm saying gen add. So that went out and got a third-party typewriter for us, okay, called set. Nothing visible has happened here yet, except that this is the way we sort of mark up what the imported types are here, or the imported typewriters are here. But what we care about is the fact that I can come back here now and I can say set. Now the set typewriter happens to be very simple. You don't have to specify a whole lot. You just say set. So then I'm going to go back to here and I'm going to gen one more time. All right. And if we come back here, we've generated a set. Okay. So we can do the usual set operation. So I can say my set equals new person set, for example, stuff like that. We've got all sorts of set semantics. Set, just to be clear, set being defined as a container that contains only unique elements, basically, takes care of duplication for you, deduplication. So yeah, it's really driven by the idea that I want other people to come in and do some sort of plugins for this. Anything that can be built around a type and that might look like something you would do in generics in another language would be a great fit here.
Are you using this package at all in anything that you're building?
I do a bit of dog food on this. So the gen code uses gen. There's a bit of self-hosting going on in there, if you could call it that. So yeah, if you were to dig into the gen code, you'll see some marked up types in there. But gen is my main Go project right now. At work, for better or worse, at work I'm all C# most of the time. We have a bit of Go here. We've got a very nice tool. You should check it out actually. Bosun, bosun.org, which is a monitoring tool, a very sophisticated monitoring tool that we built in Go. And by we, I mean other smart people, not me.
Yeah, I remember the post coming out for that. What was it, before Christmas, right?
Yeah, it's a really very impressive tool. But they built it from Go from the start. Turns out to be perfect, because it's very sort of high throughput. It has to be cross-platform, all that.
Does anybody else have any questions for Matt while we have him? No, you're all good. I don't have any questions yet on Go Miami. The Slack, let me ask real quick. This was really, honestly, I had no idea what you had built here. That's really cool.
Thanks. I appreciate it. Yeah, I'm pretty happy with where it's going. I did it, mostly as a way for me to learn Go and to dig into it and just sort of adapt it to some of the ways I think, with the hope that maybe other people might think that way as well. You can find me on Twitter. I'm at Clipperhouse, CLIPPERHOUSE. So if I glossed over anything here, if I went too quickly, or if anything wasn't clear, you should feel free to ping me there. Or just matt@stackoverflow.com. That's fine as well. That's my email address.
All right. We got a question.
All right.
So, I don't know if you can hear me. Right?
Can you hear him?
I can hear you if you speak up just a little bit.
Okay. Speak up, huh?
So, if you wanted to do something like Lodash, if you wanted to do the equivalent functionality, or underscore relation, they would be implemented in the form of typewriters in your system?
Yes, and yeah. So how about if I just bring one up here so I don't have to talk in the abstract here. Okay, so let's do this. Let's do the screen share on this.
It's sort of like a mix of a library plus bolting on the generics, right?
Well, it's not. Yeah, it's not really a library. It's a tool for generating code. So it's not something you would ever import yourself. You would just use it, unless you were actually authoring your own typewriters or whatever. But most end users will just simply type the word gen at the command line and be done. But let me show you what that looks like. That's getting shared, right? Okay, so this is what the slice typewriter looks like. And let's go to the implementation, which is here. So a couple of key things to do here. Firstly is to implement the typewriter interface, which includes this signature, and this signature. Okay. You'll see in this case it's just simply saying, hey, name yourself. In the case of imports, this particular slice writer doesn't need imports. Some people do, mostly it doesn't. And here's the writer. I'm going to shrink this down just a little bit in the hope of getting more of it on the screen. But this is typically what you'll look like. So basically, Jen will make a call to the slice writer's write method. We'll pass it a writer to write into and send it the type that we want to deal with. And then it's entirely up to the typewriter how to evaluate that type, what they want to do. So you'll see here it's very sort of stringy, what I do here. So the first thing I do is I look for the tag slice, because there can be any number of tags coming through here, so I only care about the one called slice. So I say, okay, is there a slice tag on this type? If there is, great, I'll continue, but if there's not, then it's not my business, it's somebody else's business. I do a few things here. I stole a whole bunch of code from GoSort to do some interesting things here, so I write in a little bit of license to start with, and so you'll see my writer is here, and I just write into it with some bytes. Now I go looking for some templates to give you an idea of what some of these templates look like. I think we were looking at where, for example. So here's what a template might look like. This is all Go standard templating here, so I won't get too much into the details here, but you can just see how values just sort of get substituted out here. Okay. You can go a little further on this. So I have a template for sum over here. I have a couple of templates for sum. In this case, I've added what's called a type constraint. So what I'm telling Jen here is that this template will only work on things that are numeric. You can't sum a struct. You can't sum strings. And so if you try to use this template on a type that is not numeric, Jen will stop and basically say, sorry, this typewriter doesn't support that. So we're sort of types all the way down, basically. We have this idea of type parameters. So going to my previous window, is it still open here? Yes. Each of these things has what's called a type parameter in here. So just to demonstrate that these things are actually evaluating types, I'm going to misspell this type right there. Okay, if you can see that. And I'm going to come back to the command line here. I'm going to try to gen that, and it's going to come back and say, I don't know what that is. Okay, so even though it's sort of free text here, it is all evaluated for types all the way down. So then if I fix that, I come and do it again, then it's happy.
Yeah, we only see the code right now. We didn't see the console window.
Oh, sorry about that. Okay. Well, you have to take my word for it. Yeah. Which code are you seeing right now? Are you seeing the typewriter with the type constraint, or are you seeing the code that we started with right now?
Typewriter.
Typewriter. Okay. All right. I just do want to demonstrate this to you, so stand by. Let's do a different screen share on this. Okay. So what I was saying was, so we have this idea of type constraints and type parameters. So what you'll see here is I'm basically saying I want this method outputting this type here. I want a select method that outputs dollars. So I just want to demonstrate to you that it really does type evaluation all the way down. So I'm going to misspell dollars here. Okay, it's not really a type. And I'm going to come back here. I'm going to try to gen it. And it's going to come back and actually give me the type error, just as if you were writing Go code. It basically says, hey, we don't know what dollars is. If I come back here and I fix it, turn it into what it should be, then if I gen it, it's happy again. For the sake of argument, I will also show you, again, sort of the type evaluation thing. So if I try to mark it up here and say, hey, I want to sum a person, it's going to come back to me and say, nope, person needs to be numeric here. Okay. However, this is a fun little trick here. I can do a projection. I can pass in a type parameter. So I'm just going to say, okay, I don't want to sum the person. I want to sum the dollars. So then if I do that, then it's reasonably happy about that. So then I can say something like over here. I think that worked. Oh, did I gen it? Yeah, I did. Let's just make sure that actually got genned over here. Yeah, there it is, some dollars right there. Okay. I can do something like, instead of selecting out the dollars, I can sum them. So it's also a projection. I'll come back here and run it one more time. Run that. Go run. So, and it actually adds up those numbers. You'll have to take it on faith that that's the right number. So if you've worked with generics, you will be familiar. So I've sort of glossed over some complexities here. There's a lot going on. If you've used generics in other languages, you're used to the idea of sort of type parameters, and you have some methods with and without type parameters, and we basically try to support all that in Gen.
And there's no reflection.
There is zero reflection. To the extent that there is reflection, we don't want it. That's, reflection is great. It works. It's fine. You don't have to do what we're doing here. If you don't mind reflection, if you don't mind type assertions, it's all great. But we're not doing any reflection at runtime. That is one of my key goals here, is to basically do as much work, do as much calculation, figure out as much as we can about the system at development time. So then that runtime doesn't have to incur that expense, basically. So everything that is knowable at runtime, we try to write in, allow the compiler to optimize against that, so that at runtime, no reflection is necessary. A scenario, so this is a good question. So I have not yet implemented, you've seen things like FFJSON and MegaJSON. I don't know if you've heard of those tools, but they are tools created by some other guys that will generate strongly typed JSON serializers and deserializers for you for the same reason, to get the type safety. And in the case of those things, it gets you 2 or 3 times the performance by doing it in a strongly typed way because they are so reflection driven. So if I were to do something like that for Gen, speaking of reflection, reflection is necessary, but I would do that locally at dev time. So incur the expense of reflection, analyze the types, but then when you actually create a JSON marshaller or unmarshaller, all the type information, all the member information of the struct is all entirely known at that point. So the compiler has no question, has no reason to do reflection because Gen did the reflection ahead of time.
Are you using any of the Go tooling to generate that code, or you did all that, it's all coded yourself in that package?
I coded it all myself, but it's all pretty idiomatic. It uses the text template package. I'm not using their tooling per se. Well, I take it back. I'm using the types library, which is under the tools directory, actually. The types tool is really great as an import. So it's the thing that allows me to basically say, hey, I know that this is a numeric type or is not a numeric type. If you want something to be a map key, for example, you need to know if it is what's called a comparable type. Does it support the idea of equality? And not every type does. Like, you can't equate functions to each other. You can't equate slices to each other, that sort of thing. So if you want to do a group by using Gen, I have to have something that will serve as the key to the map which results, and so I need to know, Gen needs to know, if the key you want to use can actually serve as a key. So I go to the types package, I say, hey, tell me about this type. Is it actually comparable? If it is, great. If it's not, Gen will give you an error. So yeah, check out the types package. It's really cool.
Awesome. All right, we have any other questions? Any questions on Slack? All right, so I'm going to share this real quick. So I really want to thank Matt. That was really, really awesome, Matt.
Great. Thank you so much for having me.
Well, thank you for sharing an hour of your time. And just real quick for everybody who is still on, next month, we're going to be live in India at the GopherCon India conference. I'll be there with Asul. I hope I'm pronouncing his name properly. And that's going to be a lot of fun. Also, just real quick, we've got the Go Bootcamp tour that's going to be starting right after GopherCon India, starting in San Francisco, then Denver, then Virginia, and then New York. So if you know anyone who would like to take a 3-day intense workshop, please send them that way. So let's go Miami for tonight. Thank you for everyone who's here tonight, and then we'll be watching this in the future. Thanks, Matt.
Good night. Thanks, everyone.
All right.